X59 Quiet Supersonic Flight over Land. The X59 QueSST Quiet Supersonic technology is an American experimental supersonic aircraft being developed in partnership with NASA. The Lockheed Martin Skunk Works team is solving one of the most persistent challenges of supersonic flight, the sonic boom. Overview: NASA's X59 Quiet Supersonic Technology aircraft, or QueSST, is designed to fly faster than the speed of sound without producing a loud, disruptive sonic boom which is typically heard on the ground below aircraft flying at such speeds. The project started in April 2018 with Lockheed Martin signing contract with NASA. The design was ready by September 2019. After flight clearance testing, it will include Schlieren imaging to confirm the shockwave pattern until September 2022. This mission is the culmination of decades of research, and with the X59, we are continuing to pioneer a future of aviation in which we'll see drastically reduced flight times for global traveling passengers, said Peter Coen, NASA's low-boom flight demonstration mission integration manager. Design: it will be 94 feet long with a 29.5 feet wingspan for a max takeoff weight of 32,300 lb. Propelled by a single General Electric F414, it should reach Mach 1.5 or 990 mph at 55,000 feet. Its engine will provide 22,000 lbf of thrust. The ground noise is expected to be around 60 decibels, about 1 by 1000 as loud as current supersonic aircraft. It uses a long, narrow airframe and canards to keep the shock waves from collision. As the long and pointed nose cone will obstruct all forward vision, therefore X59 will use an enhanced flight vision system (EVS) consisting of a forward 4K camera with a 33° by 19° angle of view, which will compensate for the lack of forward visibility. The X59 will fly at Mach 1.4. Here's how an object speed in Mach is calculated. Ratio is equals to object speed upon speed of sound, which is equal to Mach number. Subsonic Mach is less than 1, transonic Mach is almost 1, supersonic Mach is greater than 1, hypersonic Mach is greater than 5. Technology: when air molecules cannot move fast enough out of the way of an object with or above speed of sound, sonic booms gets generated. Various technologies are used to reduce the sound. Schlieren imaging. Schlieren photography was invented by the German physicist August Toepler in 1864 to study supersonic motion. NASA scientists use it to see the pressure waves caused by a flying aircraft pushing air molecules out of the way. Wind tunnel. Scientists use wind tunnels to test how models of aircraft will perform in flight. CFD. CFD, or computational fluid dynamics, is a type of computer modeling researchers use to show where air molecules are pushed out of the way by a moving aircraft and generate noise. These models can help engineers pinpoint the best places to alter an aircraft's design in order to reduce noise. Peoples behind X59: Peter Coen, LBFD Integrated Mission Manager; David Richwine, Deputy Project Manager for Technology; Nils Larson, X59 Test Pilot; Lori Ozoroski, Mission Analysis Lead; Walt Silva, Flight Structures Lead; Alexandra Loubeau, Flight Vehicle Acoustics Engineer. In a windowless hangar in the California high desert, the final touches are coming together on an aircraft that could reshape aviation. A needle-nosed airplane that looks more like a futuristic sketch from a 1950s sci-fi comic, all sweeping lines and unbroken curves. Designed and built by NASA and Lockheed Martin, this is the supersonic airplane for the future. And when it takes to the skies, NASA and Lockheed are hoping you won't even notice it flying by.